Okay, if we observe these three reactions which we studied in the previous classes, when calcium oxide reacts with water, it forms calcium hydroxide. In this reaction, we will see how many number of atoms are present on left hand side of the arrow mark and how many number of atoms are present on the right hand side of the arrow mark. So, here on reactant side, so three atoms are present, mainly calcium, oxygen and hydrogen. On the right hand side or product side also same, calcium, oxygen and hydrogen. These three are the atoms which are present on both the sides. So, we will count the number of atoms on reactant side and the number of atoms on product side. Calcium, how many calciums are present on reactant side? Only one. Okay. How many calcium atoms are present on right hand side or product side? It also contains only one. Next, coming to oxygen. So, here on reactant side 1 plus 1, 2 oxygens are present. On product side, oxygen contains 2 as a subscript, So, it contains 2 oxygen, oxygens are 2. Because this subscript is for both oxygen and hydrogen, because it is present in the bracket. Okay, now. So, it means 2 is for both oxygen and hydrogen. So, how many number of oxygen atoms are present on product side? 2. Next, coming to hydrogen. Here 2 hydrogens, because it contains 2 as subscript. Hydrogen, 2 hydrogens are present on reactant side. Here hydrogens 2 because it contains 2 as subscript. So, calcium, oxygen and hydrogen. So, both are same. Calcium is 1 on reactant side, 1 on product side. Oxygen 2 on reactant side, 2 on product side. And hydrogen also 2 on reactant side, 2 on product side. Next, coming to this equation. Here in this equation, zinc, hydrogen and chlorine, these three are the atoms present in the equation. Zinc on left hand side or zinc on reactant side is 1, zinc atom on left hand side is 1, zinc and right hand side is also 1. Next, hydrogen on left hand side or reactant side is 1, hydrogen on product side, here how many hydrogens are there? 2. Next, coming to chlorine, here how many chlorines are there? Only 1 chlorine on reactant side, here 2 chlorines on product side, If we observe these three, this zinc is same on both sides, hydrogen here 1 on reactant side, on product side 2, so it is not equal, and chlorine here 1, here 2, it means this is also not equal. Okay, now just remember this. Next, coming to third one, here it contains sodium, sulfur, oxygen, barium and chlorine. So, these are the atoms present on reactant side. Sodiums on reactant side are 2, sodium on product side are 1. Sulfur on reactant side is 1, sulfur on product side is also 1. Next, oxygen on reactant side or left hand side 4, here also 4. Next, barium on left hand side is 1, barium on right hand side is also 1, chlorine on left hand side is 2, chlorine on right hand side is 1. If we observe these three equations, in first equation all are equal, it means it is a balanced equation, Here the number of atoms on reactant side are not equal to the number of atoms on product side, it means it is unbalanced equation. unbalanced equation. Here this is also same. The number of atoms on left hand side or reactant side are not equal to the number of atoms on product side. So it is also unbalanced equation. Unbalanced equation. Okay now. So in these three equation, if you observe, first one is balanced equation. It means the number of atoms on reactant side are equal to the number of atoms on product side. In second equation and third equation, the number of atoms on reactant side are not equal to the number of atoms on product side. So what we have to do is we have to balance these equations. We have to balance this equation. There is very important very important role in balancing the chemical equation. So how to balance a chemical equation, we will see. According to law of conservation of mass, the total mass of the products formed should be equal to the total mass of the reactants in a chemical equation. In a chemical equation, the total mass of the products formed should be equal to the total mass of the reactants. That is law of conservation of mass. Next one is the number of atoms of each element. Number of atoms of each element should be same before and after reaction. And next one is, we can also say that atoms neither be created nor destroyed. So this is a law of conservation of mass. Balancing chemical equation. We will say one example. When hydrogen reacts with oxygen, it forms water. This is the reaction. When hydrogen reacts with oxygen, it forms water. This is the reaction. So first we have to find out whether it is balanced or not. Now we will find the number of atoms on left hand side or reactant side and the number of atoms on right hand side. So the number of atoms on, we will write one table so that we can understand is it balanced or not. We will write in the form of table. Atoms or element, left hand side, right hand side. We will see, we will take one more column as result. Okay now. So this is before balancing. First we are checking what are the atoms present on the left. Complete equation, hydrogen and oxygen. These two are the atoms present in this equation. So hydrogen atoms on left hand side of the equation or left hand side of the arrow mark are 2. 2 hydrogens are present. 2 hydrogens. On right hand side 2 hydrogens. Left hand side 2 hydrogens and right hand side also 2 hydrogens are present. Now coming to oxygen. How many oxygen molecules are, how many oxygen atoms are present here? 2. Here 1. Okay, hydrogen 2 on left hand side, 2 on right hand side. What is the result? It is equal. Okay now, so hydrogen atoms are equal on both sides of the armor, or reactant side are equal to product side. Coming to oxygen, on reactant side 2 oxygen molecules are there, 2 oxygen, and on right hand side only one is there. It means it is not equal, not equal. It means the equation is not balanced or unbalanced. It is not balanced. So this type of equation is called skeleton equation. This type of equation is called skeleton equation. The equation which is not balanced is called skeleton equation. This shows the reaction, just reaction. This is the skeleton equation. Okay now, so based on this skeleton equation, we have to balance the equation. While balancing any chemical equation, we should not change the composition of the any compound in this equation. It means, for example, oxygen 2 on left hand side, only 1 is on right hand side. For example, if I keep 2 here, hydrogens are equal and oxygens also become equal. So 2 oxygens. Is this correct? No, we should not write 2 here. Here we write subscript. So we should not write any number on subscript place. Okay now, so what happens if we write the number here? What happen? The composition or the chemical property of the complete compound will change. It means H2O is water. H2O means water. H2O2, this is completely different. It has different nature. It is hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide. So the equation is balanced, but the complete nature of the equation is completely changed. Okay now, so when hydrogen reacts with oxygen, it forms water. When hydrogen reacts with oxygen, it forms water. If we balance this equation like this by keeping number here, it will change its nature completely. Chemical nature of this water and hydrogen peroxide completely different. It means that equation is wrong. Equation will become wrong. So what we have to do? Just we have to write any number here only. It means at coefficient place. We have to change at coefficient place. Okay now. So for example, if we keep 2 here, we need 2. We need 2 oxygens. We keep 2 here, the oxygens become equal. So number of oxygens on left hand side are 2. If we keep 2 at coefficient place, the number of oxygens on right hand side also become equal. So here it will be equal. Okay now observe hydrogen. When we keep number 2 here, the number of hydrogen molecules are changed again. Number of hydrogen 2 into 2. It means 4 hydrogen molecules are present on the product side. Total 4 hydrogen molecules are present on the right hand side. Here what we have to do? We have to balance the hydrogens on left hand side also by keeping 2 here. By placing 2 here before hydrogen, now the hydrogen atoms on left hand side also become 4. Now the equation is balanced. So this equation is called balanced equation. Balanced equation. Is it clear? To balance any chemical equation, we have to follow mainly 4 steps. In that, first step is write the unbalanced equation using the correct chemical formula. This is the first step. We have to write the unbalanced chemical equation by using correct chemical formula, first step. And second step, we have to compare the number of atoms on both sides. This is the second step. We have to compare the number of atoms on both the sides. Next, third step, make sure the coefficients are reduced to their smallest whole number. Make sure that the coefficients are reduced to their smallest whole number values. And fourth step is check the answer and count the number of atoms on both sides of the equation. These are the main 4 steps which we follow while balancing any chemical equation. These are the main 4 steps. So based on these 4 steps, we will see some of the examples how we balance the chemical equation. In that first one, when hydrogen reacts with oxygen, it forms water. When hydrogen reacts with oxygen, it forms water. So this is the unbalanced equation by using correct chemical formula. This is the first step. We have to write the chemical equation with correct formulas. Okay, now so this is the first step. In second step, compare the number of atoms on both sides. Compare the number of atoms on both sides. So here I will write hydrogen and oxygen. 2 are here. Okay, now so on left hand side the number of hydrogens are 2. On right hand side the number of hydrogens are 2. On left hand side the number of oxygens are 2. On right hand side the number of oxygens are 1. Okay, now so this is before balancing. We have to balance this oxygen so that the equation becomes balanced. So here we have to balance this equation. So here hydrogen 2 2, it is balanced. So oxygen here 1, here 2. So we have to balance this oxygen. We have to balance oxygen which is present in water. So for this what we have to do? We have to add 2 at coefficient place. We have to add 2 at the coefficient place. So here after balancing we will see hydrogen plus oxygen gives rise to H2O. This is the second step. Here to balance oxygen, because only oxygen is not balanced, to balance oxygen we add 2 coefficient at water molecule. Okay, now so we add 2 here, we place 2 here so that the oxygen becomes equal, 2 oxygens and 2 oxygens on left hand side, 2 oxygens on right hand side. Now check whether the hydrogens are equal after balancing. So now the hydrogens are becoming 4, here the hydrogens are 2. So we have to balance the hydrogens also. In the next step what we have to do? We have to change the hydrogen number also by placing 2 here. So in the next step we place 2 here, 2H2 plus O2 gives rise to 2H2O. So this is the complete balanced equation. So 2H2 plus O2 gives rise to 2H2O. Now we will see whether it is balanced or not, this equation. This is after balancing. We will see here after balancing. Okay, this is the atom or element, left hand side and right hand side for this equation. Okay, na? So this is the balanced equation. We will see the number of atoms. Hydrogen and oxygen is there. Hydrogen and oxygen. So 2 plus 2, 2 into 2, 4 hydrogens are present on left hand side. 2 into 2, 4 hydrogens are present on left hand side. Here also 2 into 2, 4 hydrogens are present on right hand side. Now coming to oxygen, 2 oxygens are present on reactant side, that is 2, and 2 coefficient to 2 is there, no? So 2 oxygens are present on right hand side or product side also. So by this we can say that the equation is balanced. Now make sure the coefficients are reduced to their smallest whole number. Now the equation will write like this: 2H2 plus O2 gives rise to 2H2O. So if you see this 2, here also 1, the coefficients are reduced to smallest whole number, as already it is smallest whole number. The equation is already have smallest whole number, so no need to change this one. Now check the answer, count the number of atoms on both sides of the equation. So this is the final step. We will again check whether it is the number of atoms on left hand side are equal or not on the product side. Sorry, 4 hydrogens on left hand side, 4 hydrogens on right hand side, 2 oxygens on left hand side and 2 oxygens on right hand side. So this is the balancing chemical equation by using these 4 steps. I think everyone understood what are the steps involved in the balancing any chemical equation. We have some more examples, we will see in the next class. Thanks for watching and please subscribe my channel. Thank you.